Speed and radius don't change in uniform circular motion. Circular motion is called uniform circular motion if the object moves along a path that is any part of a circle. The path does not have to be a full circle. It can be like that car making a left turn. Or it could be the same circle over and over again, like those circles, the lines, the lights going around the circles. The radius of the circle is a constant radius. An example of a path with increasing radius would be a spiral, where the object spirals out from the center. This is not uniform circular motion because on a spiral, you're getting tighter and tighter and tighter as you get towards the middle. Right? Something like that. I suppose I could draw it, but the linear speed v and angular speed omega are both constant. If the first two bullet points are true, then either the velocity, the linear velocity, and the angular velocity are both constant together, or both changing together. An object in circular motion has a position vector that points from the center of the circle to where the object is located, because the length of the position vector is exactly the same as the radius of the circle. We're just going to call the position vector r. In all motions everywhere in physics, uniform circular motion, projectile motion, and anywhere else, the velocity vector is tangent to the path. The velocity vector has a constant length because the speed is constant. But because the velocity vector changes direction, the object is accelerating. This is really hard for students to understand. Speed is staying the same. That velocity vector is the same length all the way throughout the circle. But remember, vectors have magnitude and direction. Oh yeah. So because the direction is changing, that means your velocity is changing. If your velocity is changing, then you have to be accelerating. Any change in velocity vector requires an acceleration. In uniform circular motion, acceleration is the net acceleration. Let's be careful there. The net acceleration is always directed towards the center of the circle. Because the acceleration points toward the center, we call it centripetal acceleration. Centripetal from seeking the center. So what does centripetal mean? It just means pointing towards the middle. Or radial acceleration, because acceleration points along the line that would be the radius. The left diagram shows a car going around the circle. The right just shows the velocity vector centered on its own origin. Look at the velocity vector to the right. Do you see how it makes its own circle as the car completes its circle? The radius of the velocity vector circle is 2 pi times v. And the velocity vector completes one full circle in the period capital T seconds. Acceleration is a change in velocity over a change in time. The velocity vector changes by 2 pi v in the time capital T. So the centripetal acceleration A, while traveling in a circle, is A sub c, c for centripetal, equals 2 times pi times v divided by the period. We can change this equation into one of the more useful equations. We can take centripetal acceleration equals 2 pi v divided by period and multiply the top and bottom by the radius r. So we have 2 pi r times v divided by r times period. And if we regroup the 2 pi r and the t together, we have 2 pi r divided by t times v over r. And we also know that 2 pi r times t is speed v. So A equals v times v over r, or A equals v squared over the radius. So the centripetal, in short, the centripetal acceleration is just your linear speed squared divided by the radius. We can take the centripetal acceleration and substitute v equals 2 pi r over t. So we get this mess. So there's two pi's and 2 periods making, but we also know that 2 pi over period is angular speed, so we can also say that centripetal acceleration could equal your angular velocity squared times your radius. So if you're given your linear velocity, then it's divided by your radius. If you're given your angular velocity, then it would be multiplied by your radius. In one line, it would look like this. AC equals v squared over r, which also equals omega squared times r. That would be your centripetal acceleration. Remember what we can do with acceleration. Remember this old guy? I can throw one of those in there. That's a little sneak peek.